Hi, this record is about again solid model creation exercise in Inventor, and also one more time to demonstrate how the principal views are created in the first quadrant, in the third quadrant. Well, from the worksheet folder, say in the content of the week extended from 20 to 26th of April. Yes, open this worksheet folder and select worksheet 15. This worksheet, the most difficult one to it is geometry, is the first one. It is the pictorial drawing for a certain prismatic object. Remember, before the break, during online class meeting, I already delivered a few sentences about such a geometry. You know, cutting method is a very well-known method, okay, for the prismatic objects to create a prismatic object with mainly flat surfaces. If the volume of the part to trim is less than the total volume of the object in its final shape, yes, the cutting technology, cutting method is the recommended manufacturing method. In cutting method, yes, the first in the maximum size of the object, a rectangular prism is found from the market or from the stock, and that rectangular prism is trimmed, indent for having the object in its final form. But if the object is the one starting from a rectangular prism, applying cutting process, if there is a difficulty in setting the shape of the object, for instance, in this example, this cylindrical part, if we start from a rectangular prism and cut the material, trim the the unnecessary parts, try to have a curved surface by cutting material. It is in real life, real application, a difficult thing. Well, for instance, using planing machine, applying planing process, or crank shaper, applying shaping process, very easily can create flat surfaces. But planing machine, shaping machine, cannot be used for creating a cylindrical surface. It is almost impossible. And the other thing to check, the volume of the part to trim. If for setting the shape of the object, the part to trim by cutting the material is in the volume, it is comparable or even greater than the volume of the object in its final shape, then in real life, in industry, cutting process is certainly not recommended because it requires more energy, more time. Such a case, yes, in industrial applications, either casting process is recommended, casting method is recommended, or fabrication method, welding method may be recommended. In virtual environment, if cutting method is applicable for creating the object, shaping the object, then in virtual environments such as using 3D tools of AutoCAD or using the tools of a new generation software, one of them, is Inventor, Autodesk Inventor. start from rectangular prism if the cutting process is applicable, cutting method is applicable. Create a rectangular prism and then trim the unnecessary parts and then have the object, the model of the object in its final form. But if the volume to trim is too much in real life, and also some surfaces are curvy surfaces, so while the cutting method is not a suitable method, not an economical method, feasible method, then yes, in virtual life, say in virtual environment, in Inventor such as, well, of course, do not start from rectangular prism. Do not create a rectangular prism. Well, such a case, well, either may use completely adding method or partially cutting, partially adding. Well, studying on this example, I'm going to explain what I mean partially adding, partially cutting. For instance, here, this object, it is a single component, has such a right prismatic part and their cylindrical feature. Well, this prismatic part, the model of this part can be created adding material. This cylindrical feature can be created adding material, adding process, not cutting. But this channel, you see there is a channel here, my cursor is moving along the channel. Yes, can be created applying cutting process. Have the necessary profile and cut the material. Holes, of course, holes are created by cutting. Okay, for the holes, the process is material cutting process. For creating the channels, cutting process. But for having this cylindrical feature, it is to be adding, not cutting. Okay, now, you know, as I said, I selected from this sheet the first object, okay, to create it as model, and then, well, one more time demonstrate how the views are created in the first quadrant, in the third quadrant. Software is Inventor. Well, one more video record may follow this demonstration to answer the question, okay, then if the shape is this one, then in AutoCAD how it is created, how the model of the object is created. Well, the next video record may be on the answer of such a question. But here, in this exercise, this classwork, the selected software is a new generation software. In this course, you know, Inventor. Okay, open Inventor. It is going to be a new creation, so click on New File Creation button. And you know, in this dialog box, if it is in the pane, this pane, the list is just like this, compact, written on the templates. Clicked on the arrow, drop the list. One more, in the list, find ENUS folder, expand it with a click. And then see the options. Well, this is the option to select to say that you're going to input the values in inch, British unit system. This is the option to select, if you're going to input the size of the features, location dimensions, any number in millimeter. Metric unit system, normally in the configuration of software, in AutoCAD, also in Inventor, unit of measurement is millimeter. Everybody knows that it is so. So in Inventor, selecting metric option, then Inventor can understand that the unit of measurement for the distances and location dimensions is millimeter. If English unit system is selected, then the unit of measurement gonna be inch, you know. Okay, select metric. Why? Because, well, for this example, in this example, all the dimensions, I am sure, I know, are in millimeter. Okay. And then after selecting metric option, then since it is a single component, not an assembly, make the template selection from this part of the intermediate pane. Okay, it is to be this option. Standard means ISO standards. You know such things quite well. Just repeating the same things to call your memory. Okay, clicked on create button. And then yes, the buffer will be in followingly the 3D mode, 3D environment in Inventor. Modeling starts from sketching stage, so clicked on start sketch button. If the process to apply followingly is extrusion, is revolve, is sweep, is loft, okay, the sketch to use is to be two-dimensional. So clicked on two-dimensional sketch option. And then this is, you know, the following stage. We see in the screen, in the environment, three planes. These are defined by XYZ axis. Select one of them with a click. And then buffer will be in sketch mode. And sketch mode, draw the first sketch. Okay, for my convenience, instead of opening the worksheet and then turning back to Inventor, it may take a time. You know, my recommendation, have the worksheet in the environment of the software. How? In Inventor, clicking on this insertion button, if you're going to invoke, import an AutoCAD file to its content, of course, clicked on AutoCAD insertion button. If you're going to transfer data from Excel to Inventor, clicked on Excel logo, this one. If you're going to invoke a photograph, picture, clicked on image insertion button. And then show the address of the picture. Well, I already, from the worksheet, after selecting the part of the worksheet, here it is, the worksheet, okay, this one, took a screenshot, and then in Paint program, while pasting the screenshot, change the format from HTML to picture, and then while save the picture file in the memory of my computer, and then now gonna show the address. Okay, I know that it is in partition D in CVE 101 folder, semester folder, classwork folder, and here is the picture file indicated, and then say open. And then yes, the simulated rectangle here is the frame of that picture. At any place with a click, anchor, paste it. Press escape button. And then check whether you found the pasted picture in a suitable orientation. In the on the worksheet, it is in this orientation, and the numbers are readable in this direction. But when I pasted the picture in Inventor, well, I couldn't find it in the same orientation. What can I do? I can rotate the sketch plane. If I rotate it 90 degrees in clockwise direction, I am sure the pictorial figure will be in the same orientation as it is given or shown on the worksheet, and the numbers going to be readable for me. So, well, clicked on this banded arrow, rotate the sketch plane, of course, together with its content. And then, yes, you see, it is okay for me. Suitable orientation, and the numbers are readable. Well, since the cutting method is not a suitable method, do not create a rectangular prism for this geometry. Okay, well, this is my plan. After being an experienced person studying on the exercises, say in school, the assignments or the ones given on the worksheets, even taking the exams, then increase the experience. As an experienced person, once having a look at the shape of the object, okay, on the sheet, can say that, well, this way to follow to reach to the end, indent to have the solid model of the object? Yes, is the shortest way. Or life gonna be easier while you're applying the things, passing to the stages for you. So, well, thanks to experience, having a look at the photograph or the say the pictorial figure of the object, it is illustrated on the sheet, assignment sheet, you can say something. Well, this is my plan. I'm going to create the model of this part first, and then using furtherly adding technique, gonna add cylinder, add this rectangular prismatic extension, and then change the method. Instead of adding, start using cutting. Create this channel, create the holes, etc., and then finish. This is my plan. Well, first I'm going to draw a sketch. In my consideration, that sketch will correspond to the boundaries of this surface. Of course, for the first sketch, since the channel will be out of the case, then, well, this boundary, for instance, will extend from here to the cylindrical, the base of cylindrical part, the base of cylinder. On this surface, well, these are the boundaries. This straight boundary, skipping the channel, say that one more straight boundary. After this corner, yes, the boundary is again straight, but say this boundary is tangent to the base of the upper cylindrical portion. Well, here in the design of the object, cylinder extends in both of the directions. In the up direction, its length is 40. In the down direction, since the total length of the cylinder is shown over here is 60, 60 minus 40, thickness of this prismatic part is 10, so 60 minus 40 minus 10, this means the length of the cylindrical extension at the bottom side of the base of the object is equal to 10. Okay. Adding the material, create the upper portion. Adding the material, create the lower portion. Yes, now this intersection is the base of the boundary of the base of the upper portion of the cylindrical feature. This boundary is tangent to this intersection. Can say similar things for this boundaries, straight boundary, and then the rest is a tangent boundary. So, well, if I'm going to draw the profile for having those boundaries as the first sketch, then, well, I should start from circle creation stage. You know, if there is a circle, okay, on the projection or at the sketching stage in the sketch, necessary sketch, if there is a circle for which the size is given, location dimensions for the center point are given, then you know the recommendation. First, create the circle or circles. Well, in this example, at this stage, since I'm going to ignore the channel and those holes, okay, first stage, it is my plan. There will be only one circle to create. It is what? It is the base of this cylindrical feature. It is diameters. The diameter of the cylinder is 32. Means this diameter of this intersection is 32. Over here, I have a full circle as the base of this upper cylindrical portion. Okay, create that circle first. Click on circle creation button and then, well, arbitrarily indicate it is center. Arbitrarily make a click and then dimensional constraint. Clicked on this button, indicate the circle with a click, one more click, and then into the box write the diameter. Diameter is 32. I remember, yes, it is true, 32. And then either clicked on enter or clicked on this inputting button. And then, well, I'm going to create the boundaries arbitrarily and then upload their characteristics. Start line drawing process, and then here I started from here. Well, this is the line in my consideration. In then it is gonna be this tangent boundary. Okay, creating it to have further extension because I don't know where's the tangent point yet. Okay, and then, well, one more line, continue. Okay, this is the line to have this boundary arbitrarily created. One more line, arbitrarily created. One more line. While creating the boundary lines or the necessary lines for having the sketch in the end, avoid having a dotted line between the cursor and the characteristic point of the already drafted ones. Okay, because if there will be a dotted line, for instance here, when the cursor is at this positioning between the midpoint of this line and the cursor, I see there is a dotted line. This dotted line means if I indicate this point as the terminal point of this line, then that point and the midpoint of the other line will be geometrically related by the software. Well, that point will be in alignment with the midpoint of the already created feature, this one. So when I attempt to change the location of the terminal point via inputting a constraint, then receive a message. Inventor will say that no, cannot input such a constraint because that point is not free to take any constraint. It is already positioned with respect to the midpoint. I don't want to have such notices. So avoid from having dotted lines between cursor and the characteristic points of the already created. If there is a dotted line, move the cursor and escape from that positioning. Okay, then create such a line. In my mind, this last created one is to have this boundary, and then one more line. It is obvious that to have this tangent boundary. Press escape button, finish the process, and then geometrical constraints. Clicked on verticality constraint. Well, this boundary is perpendicular to that boundary. And well, here, this is my consideration, as if I am observing, the object in this direction. Relative to my observation direction, then this line is to be vertically oriented. Okay. I clicked on verticality constraining button and then indicate this line, make it vertical. And then, well, the other lines are relative to this one, perpendicular. Select perpendicularity constraining button and then indicate this line, indicate that line. Yes, these are perpendicular. Indicate this line, indicate that line. These are perpendicular. So since this is vertical, then the others are perpendicular to the vertical line. This means these are horizontally oriented. The geometry for this and that with respect to each other and also relative to the circle are correct. Well, this line is to have this boundary and I am sure it is tangent to the circle. So tangents is the characteristic. Clicked on this button. Indicate the circle, indicate the line. Indicate this line, indicate the circle. Have the lines tangent. Thereafter can trim the further extensions. Start trimming process and indicate the unnecessary parts. Okay. And then dimensional constraints. Well, Relative to the center of the base or the upper cylindrical part, this circle stands over there as the base of the cylinder. Okay, related to the center of that base, you see this boundary of the surface of this part is 70 millimeters away. Okay, it is a dimensional constraint, and related to the center, this boundary you see is 30 millimeters away from the center. Since the total size of this part in this direction is 60, and I see that there is a symmetry over there relative to the center or axis of the cylinder. If this is 30, then well, this coordinate value for the other boundary is 30, must be 30, because 60 minus 30 makes 30. Okay, these are once having a look at the easily gathered dimensional constraints. Well, 40 is the length of this boundary. Since this part is symmetric, this means it is the length of the opposite boundary as well. Okay, now I'm going to input this dimensional constraints. Okay, length of this line, dimensional constraints, start the process. Length of this one, 40. Length of this one, indicate 40. Okay. The distance from the center to this boundary is equal to 30. Well, from the center to this boundary, yes, the other distance is 30. So from here to there, it is equal to 60. And what else? From the center to this boundary, distance is equal to 70. Yes, that is it. Now, this is the profile to use for creating the model of this part, and also can use this sketch indicating the profile bounded by the circle, can create this cylindrical extension in the up, cylindrical extension in the down direction. This is not cutting, yeah, adding method. Okay, finish the sketching stage. And then apply the extrusion process. Well, oriented, which positioning is more suitable for your studying, using orbiting facility. And then, well, the thickness of this part has been shown over here, 10 millimeters. Okay. I'm going to create this part first. Apply extrusion process. Show this profile, show this profile. Creating the sketch, drawing the sketch. I said that top side surface of the base. So I'm going to extrude the material, add the material, not in the up, but down direction. Clicked on flip flop button. Okay, well, the sketch is on the top side of this prismatic part. Thickness of the part is 10, so clicked on apply. Since I'm going to use the same sketch more than one time, I clicked on apply button, not OK button. And then, well, can create the cylindrical extension, the length of the upper portion. Yes, have a look at the worksheet here, 40 millimeters. Okay, then indicate this profile, and 40 is the distance between the plane where I have the sketch, which I indicated that profile, and the tip of the cylindrical extension. It is 40, so write into the box 40. Here is the upper cylindrical, upper portion of the cylindrical feature. Apply. And then, well, I already calculated that the at the bottom side cylinder extends, say, and the length of that extended part is 10. But here, applying the extrusion process will indicate this profile one more time in the opposite direction. Yes, flip-flop. Well, from the profile, it is over the surface of the base, top side surface of the base, to the tip of the lower cylindrical extension. Distance is equal to 10, thickness of this part. Length of the extension at the bottom side is 10. So here into this box, 10 plus 10, 20 millimeters must be written as the distance from the sketch plane, where I have the profile, to the tip of the cylinder. Okay, and then I think, well, at that stage in this dialog, these are all. So since at this stage I'm not going to create one more feature, I indicated the necessary ones and had the necessary the models of the features at this stage. Then say not apply, but clicked on OK button. Okay, and then, well, yeah, I'm going to teach to the software that it is the suitable positioning, because now here the model in this orientation you see is as it is shown on the worksheet. Okay, well, this is the most suitable positioning for me for this model. So, well, if it is the suitable positioning, then, well, for your convenience, define that positioning as the home positioning. Bring the cursor onto the cutter symbol, right click, and then set the current view as home. Jump to here and select fit to screen option. And then, well, it is already time to pass through saving stage. First saving stage, select save as option, and then show the address for the file. It is CVE 101, this folder, that folder, and then generate the name for this file, surname, ID number, worksheet, it is from worksheet 15, WS15, first object. To say object, I'm going to use O, letter O, first object O1. Since on the sheet there are totally 4 objects, to their photographs, to their pictorial figures, say I order the objects, first object, second object, etc. And date of the time, April 28. Click on save and then continue. Now here from the worksheet I see this part of the base, there is a rectangular extension. Its thickness is 10. It is bases at the bottom side of the already created portion of this part. Okay, its length, total height is 30, but relative to the bottom side surface, its length is 30 minus thickness of this part 10, 20. Okay, I'm going to create this extension, this stage. I know that it is bases at the bottom side, so rotate it and see the bottom side surface of this part. And then on this surface, take a sketch right click, new sketch. And then create the sketch. Sketch is to be the base of the rectangular extension. To be able to create the sketch in the correct size and at the correct place, I need to indicate this as the reference and this one or that one as the shoulder, Okay, if you're going to apply trimming technique or if you're going to input dimensional constraint. Whatever the technique is, well, both of the cases need to apply project geometry process, have the image of this boundary, have the projection of that boundary. And then, well, the terminal point of this boundary can snap cursor. Start rectangle creation process. Why? Because the extension to create is a rectangular prismatic extension. So its base is a rectangle. Okay. Snap this terminal point. You see when I broke the cursor to the vicinity of the terminal point of that projected boundary, it is just at the corner of the space. You see, start seeing a green dot. Green dot is the highlighting symbol to say that cursor is sufficiently close to that characteristic point, and if the mouse is left clicked, it can snap the cursor. In other words, this means you indicated the point. Okay, indicate this point as the corner of the rectangle and then create the rectangle. Since the other corner is not a characteristic point, if it were over there, then I would snap the terminal point of this projected line. If it were at the midpoint of this, then I would snap it. But the corner point is not a characteristic location. What can I do? Furtherly extend it. Have such a further extension. Okay? And then, if you're going to use trim technique, trim the further extension. Or you can set the size of the rectangle, inputting the size value as a constraint from here to there. Well, demonstrate both of them. First, say that you selected trim technique, clicked on trimming button, and then trim the further extensions. So, well, you see, precisely managed to locate the terminal point of this boundary along this projected one. Well, this line, this line, this line. These are the boundaries, remaining boundaries of the rectangle after trimming. And this green line, well, you see I use that projected boundary as a shoulder to apply trimming. And also this projected boundary from here to there is the closing boundary for this profile. Yes. And then, well, the rest say that the thickness of the extension is 10, so distance from here to there is 10. Yes, now that is the profile. 3 drafted ones and this projected line form a rectangle as a closed profile to indicate. Okay, I trim the further extension, or say oops. Instead of trimming, well, I know the height of this rectangle from here to there, it must be 60. Yes, you see, not trimming, but inputting its size value, I managed to have the rectangle just to its boundary. It is along this edge precisely, and it is in this direction correct size. From here to there, distance is equal to 10. And then, yes, trim or just input this constraint. Okay, finally, I have the necessary profile over here. Finish the sketching stage and apply extrusion process. Yes, the extrusion direction is correct. Otherwise, I would click on flip-flop button. Okay, well, Inventor waiting for the extrusion size. From the sketch, well, I drafted the sketch on the bottom side surface to the tip of this extension. I already calculated from the given pictorial figure. The distance is 20. And then say OK. Yes, you see here, as it is shown on the photograph or pictorial figure of the object, I have the necessary extension. Okay, you see, up to this point I used adding technique. I added the material, had the cylinder, added material, had this extension, etc. And now the time to cut. Well, here at this stage, of course, order is not so important. Either you may create this hole or this channel. Which one you prefer? The order is not so important. Create the channel and then create the hole, or vice versa. I'm going to create this channel first. Well, have a look at the channel. Well, if I say that this surface is the left side surface of the object, it is a profile side, then can say that this channel has two profile surfaces. Well, over one of them my cursor is moving, and at the opposite side to this surface there is another profile surface, and the bigger surface of the channel is horizontal surface. Okay, well, the location dimension for this profile surface with respect to this intersection, it has been shown, is 10. Well, the location dimension of the profile surface, it is over there, relative to the most left surface, 14. And the height of this channel in the vertical direction, distance from this surface to the horizontal surface of the channel, is 3. Okay. Knowing such things, okay, dimensional constraints, then turn back to here. This is my plan. Over this surface, after taking a sketch, right? Well, in cutting method, you know, first select the surfaces to create their models. Here, one more time, turn back to. I selected this profile surface, that profile surface, and this horizontal surface. 3 of them perpendicular to where? Perpendicular to this most front surface. Since these are perpendicular to most front surface, then draw the necessary sketch over that surface, most front surface. Take a sketch right on the most front surface, and then draw what? Draw the edges of the selected surfaces. Edge of this profile surface, okay, while the object is being observed in this direction, is seen as such a vertical line. The edge of the other surface, this vertical line, and edge of the horizontal surface, that vertical line. Since the surfaces are perpendicular, okay, for having their edges in sketch mode, well, can use a rectangle, create a rectangle. This is my plan. Left click indicate the surface, right click the mouse, and then take a sketch right. Okay, since the surface of the channel are all perpendicular to the side of the object, yes, draw the necessary sketch on that side surface, most front surface. I know that while the surfaces, profile and horizontal surface, are relatively perpendicular to each other, as the edges of those surfaces, I can use a rectangle, start rectangle creation process, and arbitrarily create the rectangle. I'm going to use trim technique. I had such further extensions to be able to have the terminal point of the edge view of the profile surfaces here and there precisely along this boundary. Well, here, to be able to trim the further extension, I need to have a shoulder. Shoulder is the edge of this surface. Edge of this surface. Project geometry process and then indicate the edge of this surface. Well, this created projection going to be a shoulder, applying the trimming process. And also with respect to this shoulder, with respect to project line, I'm going to input the height of the channel. In other words, location dimension for the horizontal surface of the channel relative to here, it is, you know, is 3 millimeters. Okay. Well, this coordinate 14. Okay. The other coordinate is with respect to this intersection. So to be able to trim, yes, after having this projected edge, then I can trim the further extensions, trim this, trim this, trim that. Yes, I use this projected line as a boundary to say that rest is unnecessary. And now with respect to this boundary, I'm going to input dimensional constraint from here to there. Distance is 3. Okay. I think I made a mistake. 30. Okay, press escape button and correct this typo. Double clicked on the wrong dimension, null constraint, and then correct it. Not 30, but 3. Okay. And then, well, from the boundary of this surface, since this boundary and the terminal point of this created green line are coinciding, so no need to create the projection of this boundary. Okay, but I need to create the projection of this intersection to be able to input the other constraint. Start project geometry process and indicate this intersection, have it as projection, and then dimensional constraint from this projected intersection, projected line. It is the projection of the intersection formed by the tangent surface and that most front surface to the profile surface of the channel. In my consideration, this short vertical line corresponds to the edge of one of the profile surfaces. Distance, I know that is 10. Okay. And from this boundary to the edge of the other profile surface, distance is equal to 14. And now, this lines, this is the edge of profile surface, this is the edge of horizontal surface of the channel, this is the edge of the other profile surface, okay? And this green line from here to there, you see, form a region, closed boundary, say closed profile. Size correct, shape correct, and this means sketching is to be ended, finished sketch. And then now the rest is cutting process, extrusion, okay? Now Inventor offering material heading, no, it is cutting issue. So select cutting option. And then how many millimeters is the cutting depth? If you want, you may hold the golden arrow from it set and then simulate the cutting process. Assume that crank shaper removing the material. Cut, 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 and then reach to the atmosphere. Or, since it is a true extension, truly cutting, well, from here, select on True All button. Okay, and then say, okay. Here is the channel created. Save the file one more time, and then continue. One more time apply cutting, but it is for hole creation. For hole creating the holes, we have a special tool, hole creation tool. No need to draw a sketch if the edge of the hole is over a flat surface. Just start the process with a click. Extrusion process, revolve process, sweep, loft require fresh sketches. But whole process, no, does not require, of course, if the edge of the hole is over a flat surface. You remember it was a time how many weeks ago I talked about hole creation tool. I said that after creating the hole creation button, then in the dialog box, if you selected this type option, this means it is a non-standard hole. Customized tool, and then into this box write the diameter. If the hole is contour bore hole, select this option. Contour sink hole, select that option. Okay. But if the hole is a standard hole means is the hole through the hole a standard bolt or cap screw going to be inserted, then depending on the size of the standard fastener, bolt or cap screw, hole diameter of the hole is to be determined. Inventor has all the standard values for the fasteners in its library. So after selecting this option, it is to say that hole is a standard hole, then from the list select the acronym of the standardization association. It is to say, for instance, the bolt has been defined, shape, size, manufactured in accordance with the written things in the document published by ISO. Okay, and then select the type of the fastener from the list, select the size of the fastener from the other list, and then so on and so forth. But here the hole to create over there is not a standard hole. It is a customized one. You see here in the text there is no such a info. If it were a standard hole, then there will be a technical note to say that it is the hole for housing a bolt or cap screw. Since I see that the diameter of the hole is simply shown 22, there is no depth value, there is no technical note to highlight that it is a standard hole. Yes, can say that this is the annotation for a simple hole. It is truly extending. Okay. And its value is 22. So select this customized hole option. Okay. Well, if there is such a history, previous usage, you selected, for instance, countersinked option. So, well, although here it is not a countersinked hole, but a truly extending simple hole, you see it is in the simulation still exists. Such a case, if there is a history in the dialog box, well, have already selected hole type and already input dimensions, then how you can clear the history, reset the tool? You know the answer by clicking on None button. After clicking on None button, this means you clear the history. And then select this option in this example because the hole is a customized hole and it is truly extending. So from this list, select Not Distance option. If it were a blind hole, I will select Distance option and input the depth of the hole. Okay, but it is truly extending hole, so select True Hole option. And then into this box, write the diameter. Diameter of the hole is 22. The rest. Bring the surface onto the starting surface. Hole starts from where? Starts from this surface and indicate that surface. And then from the pictorial figure, I see the hole is coaxial hole. Relative to where? Relative to the axis of the cylinder. So cylinder and hole are coaxial entities. How teach to the software that hole is coaxial? The axis of the hole and the axis of the cylinder are coincided. Just simply indicating the surface of the cylinder or edge of the cylinder. It is to say that the axis of the cylinder and the hole are coaxial. Just click and then the rest is achieved by the software. Now the hole is at the correct place. Okay. Clicked on OK button. Okay. Yes, why not? And then save the file. Okay. Well, in the design of the cylindrical part, I see that there is a channel here, rectangular prismatic channel. Yes, make a zoom in. You see, it is truly extending. And then see the given or the shown size values for this channel. Well, the depth of the channel in this direction is 6, and you see the surfaces of the channel, this and that, are symmetrically distributed with respect to the center of the edge of the hole. Well, and then here there is a dimensional constraint. From the reversal of direction point of this circle, it is this point, to the profile surface of the channel, the edge of the profile surface or is profile surface, distance is 25. Okay. I know that when I trying to input this constraint, when I indicate the circle, then Inventor will distinguish it as center. And relative to the center point of the indicated circle, the dimensional constraint going to be, gathered, recorded. Since I know that it is true, then well, before focusing the attention to the necessary sketch, make the necessary calculation. Well, from this point to the profile surface of the channel, distance 25. Diameter of the hole is 22. So radius of the hole is 11. From this reversal of direction point to the center, distance is 11. From here to there, distance is 25. So 25 minus 11 makes how much? 11, 14 millimeters. Okay. Now, I know this dimension, so see the rest. Take a sketch right on this flat surface, new sketch. And then, in sketch mode, create a rectangle with such further extensions, and then upload the dimensional constraints. Doing this, I need to use the edge of the projection of the edge of the hole, project geometry process, indicate the edge and have it as projection. After having the projection over the sketch plane, then can indicate it as center point. And also this projected line going to be a shoulder to trim the further extensions. Yes, trim the further extensions after having the green line, of course. Okay. Otherwise, trimming process will completely delete the boundary. But here, creating the projection of the edge of the hole, I had such a shoulder and can say that at the trimming stage, after this shoulder, this part is further extension. And relative to the center of this circle, can input the constraints, dimensional constraints for this, for this, for that. In my consideration, this line and that line correspond to the edge of this frontal surfaces, and the other line corresponds to the edge of this profile surface. Okay? You know, since those surfaces are perpendicular to this flat surface, I took a sketch right in my method. You know, first select the surface to create it as model, and then see that surface is perpendicular to where? Answer the question. Here, these are perpendicular to this flat surface of the ending surface of the cylinder. I took a sketch right on that surface, and on that surface draw the sketch. Sketch is to be mainly the edge of the surfaces which you need to create them followingly. Okay, you know this technique, cutting technique. And then yes, I had these lines, and in my mind these are the edges of the surface of the channel. And then I know location dimensions. Well, from the center to this line, yes, I know that when I indicate the circle, it is center point will be the reference. So, well, already calculated. Distance from here to there is 14. Am I true? 25 minus 11 makes 14. Yes. True. From here to there, distance 6. But there is a symmetry. So, from the center to here, distance is equal to 6 divided by 2, 3. Okay. And the total distance from the frontal surface to other frontal surface is 6. Okay, well, the profile, you see, is the region bounded by the the lines, those correspond to the edges of the surface of the channel, and the closing boundary is from here to there, the path of the projected boundary. Yes, this green line and those drafted ones, you see, just bounding a closed region, so it can be indicated. Finish the sketching stage and then the rest. Now here method is cutting. Apply extrusion process. Okay, show this profile, not in adding but cutting mode, and then cutting length, it is truly extending channel, so click on through all option and then say okay. Yes, you see, managed to create the channel. It is truly extending from the topmost level to the bottom, truly extending. The other channel is a blind channel in the vertical direction. It is a symmetric channel with respect to the center of the edge. Span, the width of the channel is 6, okay, and it is symmetric distributed. And the height of the channel is over there, shown over there with this leader line, 7 millimeters. Okay, see how this blind channel can be created. Take a sketch, write one more time on the surface. Okay. And then create a rectangle arbitrarily with further extensions. Okay, and then project geometry process. For having a shoulder here is necessary. Shoulder, this projection of this one necessary. And then trim the further extensions. Trim this part and that part. And now my consideration, this line is the edge of one of the profile surfaces of the channel. This is that of the other. And I know from the center to this boundary, distance is equal to 3. And from here to there, width of the channel is equal to 6. Finish the sketch. And now sketch is just to have such a region, while this line and the portions of the projected boundaries, you see, form a closed profile. Apply extrusion process, indicate that region, but to cut material, select cutting option, and then well into the box write the height of the channel, it is 7. And then say okay. Yes. The channels are okay. Clicked on save button. And then well, the last feature to deal features are the holes. Well, here along the channel there are 3 holes. Well, from the annotation I see that for all of them the size is the same, it is 6. Since in this hole annotation there is no depth value, this means these holes are truly extending holes. Okay, well, for the holes I know what? I know that these are simple holes, diameter 6, and the location dimension for the axis, well, with respect to this profile surface, 8 millimeters. Okay, with respect to one of the limiting boundaries, this or that, well, I think yes, need to calculate the coordinate value. Total depth of this part or the length of the channel is 60. Okay, distance from the center of this to the next, 20. From here to the center of the third, 20. So 60 minus 20, 40, makes 20. 20 divided by 2 equally distribute. You see it is symmetric. This means from the center of this circle to the edge is equal to 10. One coordinate for the center is 8. Relative to here, the other coordinate is 10. And the diameter is 3. Okay. The diameter of the holes are the same, and it is equal to 3. Okay. Whole process does not require a sketch, so directly start it with a click. And then in the dialog box, I know it is a non-standard tool, selected this one. It is truly extending. The diameter of the hole into the box write 6, and then the rest. Relative to here, first indicate the surface of the starting surface of the hole, and then indicate the reference feature. It is this intersection. With respect to that intersection, I see the location dimension is 8. Okay, into the box write 8. Okay, and then relative to this edge indicated, I calculated the location dimension, it is 10. And then say apply, and then create the second, create the third. But for the second, third, I don't want to deal with constraint inputting stage. So I'm going to say, okay, finish the running. And for creating the others, why not? You see, these are identical holes and equal distance away. 20, 20. I can use array copy facility, yeah? I'm going to use array copy. Instead of one by one creating, clicked on array copy process button. And then, well, I'm going to create not the object, but the copy of the feature of the object. So this button is correct button. Feature indication button is on. So, well, the rest, bring the cursor to the edge of the hole. And after seeing this highlighting, click the mouse. I said that it is the entity. And then, well, clicked on direction indication button and then indicate this boundary or that boundary or this boundary or this boundary. It is just a path. Along this path or as parallel to the path, the other members of the family of the pattern will be created. I'm going to indicate this one as the direction. After indicating the direction and H to say that it is the direction feature, then, well, a green arrow and the simulation will appear in the screen. See the direction of the green arrow. It indicates the sense in which the copies will be created. No, I'm sure the copies are to be not here but there. So flip-flop. Clicked on this flipping button and then have the simulation in the correct direction. How many holes we have to create? 3. Okay, distance between them is 20. That is it. And then say okay. Yes, using array copy technique, probably at a shorter time, relatively little effort, managed to create the copies. Okay, similarly, have a look at here. There are 2 holes. Okay, well, the diameter of both of them are the same, 12, 12. Okay, well, the location dimension for the longitudinal axis of this hole has been shown over here. How much? Well, this collaborate box is preventing. So, well, from the worksheet can see 15. From the center of this hole, edge of the hole, to this intersection, distance is 15 millimeters. In the vertical direction, the location dimension for the axis of the hole is 10. Yes, 15, 10. These are location dimensions and diameter is 12. Okay, then create the hole. Start hole creation process and then, well, into the box write 12. It is a simple hole. 12 is the diameter. Write 12. Truly extending. Yes, it is correct. But here, true all option, for instance, indicate the starting surface. And then, if you select true all option, because it's a truly extending hole, but be careful. If, well, in the design of the object, do it again. Well, by mistake, I clicked on escape button. So, well, do the same thing. 12 is the diameter and indicate the starting surface. Well, if you select true all option, saying that yeah, hole is a truly extending hole, but be careful. After the hole, in alignment with the hole, you see there is one more solid feature. True all option in such a case should not be selected, because true all means whatever exists in this direction as solid, then cut all of them. Well, this part of the object, there is no hole, there is no cutting. So in such a case, if after the solid feature, which is the feature in which you need to create a hole or empty space, okay, if there is one more solid feature in alignment, okay, do not select true all option, because true all option will cut the material not here but also at the other part. Such a case, well, from this option list, select two option, two. Okay, it is a trick. And then, well, as the target surface, okay, indicate this ending surface. Or if you know the length of the hole, select from the list distance option and write the thickness, write the length. But here true option is preferable. Instead of saying true all, I said 2 and indicated the target ending surface. And then say OK. Well, not OK, sorry. I said that 2 there, but location dimensions. Well, I forgot to indicate the location dimensions. Indicate this h, okay, and relative to that h, I forgot the number, coordinate is 15. And relative to the bottom h, this boundary, it is 10. Okay. Indicate the location dimensions. Well, here it is 15. And indicate that h, it is 10. And then say 2. Or first say to this surface and then indicate the coordinate, input the coordinate values. The order is not so important. And then say apply. And then similarly create the other hole. Okay. Array copy, I think, well, not necessary, because whole process still is in execution. And then only thing to see here is that for the second hole, location dimension relative to the center of this is 30. Okay. Other location dimension is 10. Okay, then continue. So click on apply button. And then the other hole. Indicate the surface, starting surface, and then as the reference, indicate this one, and into the box write the distance as equal to, actually forgot the number, one more time have a look at, 30. Write 30. Oh, well. It became wrong, so well, sorry. I indicated the age of the hole, but Inventor measured as if it were the diameter. So well, cancel this operation, saying what a pity, start the whole process again. Okay, diameter is 12, starting surface is this one. Okay, and then the location dimensions from this edge 10. From that edge, I don't want to indicate the edge of the circle, say other hole, indicate this reference feature, and then make this calculation. 15 plus 30, it makes 45. And then, yes, the same notice, do not say true all, because you see, if we say true all, then this solid part will also be cut. Say to option, to, and then indicate this target. To where? To this surface. Okay? But to be able to cancel the orbiting process, orbiting stage, I clicked on escape button and lost the process. So well, what a pity. Indicate, start the process one more time, indicate the starting surface, location dimension, one of them is 10, the other location dimension from here to the center, it is 30 plus 15, 45, and say not truly extending, select to option, to, and indicate the ending surface, and then say OK. Yes, I think it is OK. Can say that created the model of the object. I have all the things. Well, it is the model, but not the solid model yet. Make it solid model. I'm going to say that it is made of brass, soft yellow brass. Right click and then assign. Here is the model of the object. It is made of brass, yellow brass, or not yellow brass, but say stainless steel, or say that made of wood, maple, birch, cherry. No, say that it is made of low carbon steel, okay, stainless steel. Okay, say that low carbon steel, low carbon steel. Cheaper material. Stainless steel is expensive material. It is a cheaper material. Okay, carbon steel is a cheaper material. But say the advantage of carbon, ordinary steel, is it is price. It is cheaper. But disadvantage is that it can react the oxygen of the atmospheric air. Okay, so ferrous oxide as a result of oxidization say produced, well, starting from the surface, well, in time we have rusting. Okay, to be able to prevent rusting, well, the famous method is that to be able to have the manufacturing costs in the manageable order, to be able to say find for this product a place in the market, yes, aim to decrease the cost of manufacturing. How? Using cheaper material. But if it is going to be used in contact with, for instance, water or atmospheric air, then to be able to prevent corrosion, oxidization, what is the thing to do? Painting. Okay? Well, so in the scenario, say that surfaces are to be painted. Okay, material is not stainless steel, but ordinary steel, low carbon steel. Left clicking indicate this, right click and assign. And then close this dialog box. Yes, it is made of ordinary steel. save the file one more time. And then, in the scenario, say that the surfaces are to be painted with a dye. Why? To prevent the corrosion. It's a very famous method. Now here in this example, I want to answer that question. Yeah, in virtual environment, how can we have such a surface effect? Say that surface has been painted. Well, classical method. If you're going to paint only one surface, for instance, this surface going to be in contact with atmospheric air, but not the rest. Well, if it is the case, then one by one, how the surface can be painted. Now here open a parenthesis after finishing the model creation stage and talking about surface painting. In Inventor have such an illustration and to draw the attention of the reader that yeah, this is an object, its surfaces are to be painted. If all the surfaces going to be painted or some of the surfaces painted. First answer the second question. How we can have one of the surfaces or some surfaces say in the color of a certain dye and say that painted. Here is the answer, classical method. Two methods for painting the surfaces in virtual environment. One method say that old method, but still it is applicable, so say classical. Indicate the surface with a click, right click the mouse, and this menu will drop to the screen. From the menu select properties option. In this dialog box, clicked on this listing arrow, the listed ones are color options. For instance, that surface you selected which kind of dye, say that cyan or canary or gray or red. Say that paint the surface dark red or light red. Say that light red. Select this color and then say OK. That is it. You see, have such a surface effect. Well, in this classical method, you cannot change the color tone. Okay? And here, if you're going to have another surface as painted, then indicate the surface, left click, right click, and then properties in the classical method, and then select the dye option, paint option from the list. Well, light red, and then say OK. You know, this is the classical method. But if you want to change the color density, lighter or darker, then say oops, undo. Well, then select this option. You see along the quick access menu bar, there are two monitors. In the monitor from the left, first monitor, after inputting the material, see the name of the selected material. Steel carbon is the one which I selected as the material of this object, and it is monitored within this display. Okay? And then, well, there is one more display and listing arrow. In few minutes, I'm going to talk about it. But first see, today, the alternative painting facility to paint the surfaces one by one is this facility. There is a color, it looks like pie chart for me, and on the button there is a little injector symbol. Clicked on this button, and well, this is the gripping point. You can hold it and place a suitable location. It is like a joystick. Using this tool, um, select the color option, main color. Say I selected green. With a click, making this analysis, I said that green. And then you see there is a diamond at the center and a square. Hold the square with a click and drag over the diamond. Okay, moving the square can change the color density. Okay, indicate the surface, for instance. Okay, and then select green option, and then yes, hold the square and with a click, and then move it over the diamond. You see, while moving the square over the diamond, correspondingly changing the color density, darker, lighter. This is to have lighter. This part, if you move it, to have the green, dark green, so on and so forth. You see, if you use this tool, you can change the color density. And then clicked on Apply button. And then select the cylindrical surface, for instance, with a click, and then select the red color, and then hold the square with a click, and then move it over the diamond. Yes, this is a painting tool. And then clicked on Apply. Same color or different colors you can select. Okay. And here there is a long list. You can directly select, for instance, from this list, dark blue option. And then you see, after selecting dark blue, this means I selected this color tone, and indicate the surface with a click. Yes, you see it is going to be painted in this color. And then if you hold it, hold the diamond, and then move it, hold the square and move it in the on the diamond, then can make it lighter or darker. Yes, that is the tool. Say OK and close this dialog. Yeah. How the paint can be removed? Well, for instance, this surface for painting, you selected classical method, property technique, and then say that the color of this part is cyan. That surface. And then how can you remove the paints from the surface? It is an editing technique. You set such a color for the surface, you painted, and then you gave up. After learning that, say the surface is no need to paint because it is not going to be in contact with atmosphere, in contact with humidity material, wet material, for instance, sea, water. Okay, so you gave up, no need to paint it. How you can remove the paint? Next to this tool, there is one more button. It is like a pie chart, but here there is a cross on it. It is the tool to remove the paint. Okay, select the surface with a click, and then clicked on OK button. But if not only for this die, but all the dies already painted surfaces, from all the painted surfaces, the dies are to be removed, select all button, and then say OK. Then all the dies will be removed from the surfaces. Yes. And then lastly, about painting, say that if you're going to paint all the surfaces, well, indicate surface, assign the paint, indicate surface, select the paint. It is too long. If all the surfaces are to be painted, then yes, indicating one by one and painting the surfaces may take lots of minutes. For the objects, they have lots of surfaces. Well, in such a case, to be able to paint all the surfaces, well, see, drop this list, not this one, but the second display. There is a listing arrow. Okay, drop this list, and from the list, select a color option, smooth purple, for instance, with a click. That is it. This is the tool to paint all the surfaces. Okay. Purple, turquoise. Yes, it is painted turquoise. How you can remove the paint? Click on this and select all, and then say OK. Yes. Okay, I'm going to paint all the surfaces. Drop this list, and then from the list select color option. Which option? Violet. Oh, no, I don't like this color. Change the color. Light orange, dark sea green. Okay, like this color. Yes, yeah, well, ending this part, save the file, and then before finishing this exercise, as I said at the beginning, not only model creation, but to allow you to see one more time view creation part. Okay, for this object, create the views. In doing this, I'm going to define this side as it is front side. Okay, that side top side. And for this geometry, 3 views are sufficient: front, top, left. First quadrant projection. To say first quadrant, select metric option, and then from this template option, make the selection on ISO template option. IDW is the extension. You know the rest. We have A3 size paper. I'm going to have 3 views, and gonna check whether A3 is a suitable size to have the images of the object under a certain suitable scale factor. Start the view creation process, clicking on base view creation button, and then, well, if the model is still active in the environment, then Inventor automatically detect that it is the object for which the views are to be created and start the simulation. If the model were inactive, not in Inventor environment but in the memory, then I will click on this search button, and in the search dialog I will show the address of the solid model. You know this. Okay, since there will be no sectional view, the first style button is the correct button to click. Scale factor 1:1 I think is suitable. Orientation of the body, to be able to allow yourself to see the model as you fixed as it is home positioning. Clicked on cutter symbol, and then while observing the simulation as you selected in home positioning, can much more easily say which side you selected, front side of the object, then see which surface of the cube is parallel to that side. In this example, this surface of the cube is parallel. So indicate that parallel surface of the cube. It is to direct the model such that it is corresponding frontal side surface will be parallel to the surface of the paper. This is the method of teaching. And then drag the simulated view to the correct place for the front side view. This is the front side view, and then the rest, click, and then say that OK. And then, well, the format requirement satisfy the balancing requirement. Distance A, distance A, distance B, distance B, and the space between them should be in the same order. Okay? First angle views, first quadrant views. Don't forget to show the axis of symmetries, annotation. Okay. If there is a full circle, horizontal vertical axis, yes. On the left side view, this is a full circle, indicate have the symmetry axis. This is a full circle, have the symmetry axis. On the top view, this is a circle, indicated have the axis. But since there is a cutting here, this axis is to be, couldn't be created. It is to be extended. I'm going to make this extension after having the axis for the other holes. Indicate, indicate, and press escape button, and then hold this gripping point, the end of this axis, and then stretch it. Yes, for having the rest of the vertical axis. And then the others, longitudinal axis. For the revolved features, on their lateral side views, we need to show the longitudinal axis. Cylinder is a revolved feature, so show the longitudinal axis. If I indicate this surface limit line, indicate that surface limit line can have longitudinal axis. One more time indicated, this one indicate and have the extension. Well, these hidden lines correspond to the image of a front view of this hole, this hole, this hole. They are in alignment, so the same projection corresponds to the images of all of them. Indicate the surface limit lines between them for having the longitudinal axis. This is the lateral side view of those holes. Okay, they are coinciding each other. Between them, longitudinal axis is needed. Okay, on the top view, this hidden rectangle corresponds to the lateral side view, top view of the holes. Their dimensions is 12. Okay, indicate longitudinal axis. You know, axis is to highlight that such a part on the projection, it's a rectangle, is not the image of a rectangular prism. It is to say that image of a revolved feature show the longitudinal axis. At the view reading stage, it is quite meaningful. If there is an axis, then this means it's a revolved feature. And on the left side view, yes, for this cylinder, indicate the limiting lines and have the longitudinal axis. Instead of indicating this and that, I clicked on escape button and I'm going to use stretch technique. Yes, I extended the line using gripping method. Yeah, yes. On this view, this rectangle, this rectangle, this rectangle, the lateral side views of the little holes show this, show that, and have the longitudinal axis. Show this, show that, have the longitudinal axis. For the axis of the third, yes, the longitudinal axis of the cylindrical part can be used. It is coinciding with that one. Okay, first angle views are okay. The rest, fill in the title block, show the quadrant symbol, and show the dimensions. Dimensioning part is still out of consideration at this stage, because probably next week it is gonna be the time to talk about dimensioning part. I'm going to deeply educate you on dimensioning part, format, rules, etc., and size tolerances, and then, well, it is going to be included. Show the dimensions. Okay, but you're not ready yet to show the dimensions. You should be first educated. Save this file. Okay, in the memory, saying that worksheet 15, object 1, okay, April 20th. Well, here, to be able to make the file distinguishable and prevent clash in the memory, I'm going to name this file saying first angle. Okay, first quadrant. Here I selected for this set of views first quadrant. So Inventor, if detects that there are some changes have been done, so ask us whether it is the decision, then save the file. Yes, all those changings are acceptable for me. Select yes to all option and then click on OK button. And then before ending this classwork, then pass through the view creation stage, but selecting third quadrant. Say that the drawing is to be processed in the United States, Canada, or Australia, India or Pakistan. Okay, or Australia. Third angle are preferably used in such countries. So, new file creation button, select English option to say you select the third quadrant and make the template selection on this option ANSI. Okay, we obey to the rules of American Standardization Association, so select ANSI template. Clicked on create button. The automatically selected paper size is D size. You know, in American system we denote the papers not saying A1, A2, A3, A4, but say A, B, C, D. D is 2 times bigger than the necessary order. Change the size of paper, broke the cursor onto sheet icon, right click the mouse and from the menu select edit sheet option. You know such things quite well. From the list select a more suitable paper size to save forest. C size is sufficiently large and then say OK. And then we'll start the view creation process. OK, clicked on cutter symbol, enable yourself to see the model as you familiar while you're creating it as model. And then you know it is the teaching method. Clicked on the parallel surface of the cube. Okay, it is parallel to the front side of the body to direct the front side of the model as parallel to the surface of the paper. So thereafter can say that it is the front view. In the third angle projection, front view, for the front view we use such a path over the paper. So drag it to here and then move the cursor in the up to create over there have the top side view. Move the cursor here to have over there the right side view. These are principal views in third angle. Scale factor 1 to 1 is suitable. If I select 2 to 1, try. No, too much. The space left may not be sufficient to show the dimensions. Between the views, well, followingly, there will be dimensions. So 1 to 1 is the suitable scale factor. And then say OK. The rest is the same. Balance the views if couldn't find them as centered. And then show the axis of symmetries quickly. OK. This. And here show the axis of this, show the axis of that. The others longitudinal axis. Clicked on this button. On the top view show this surface limit lines and have the longitudinal axis between them. On the front view show this, show that between them have the longitudinal axis, this and that longitudinal axis. Show this, show that have the longitudinal axis. Show this, show that have the longitudinal axis. Indicate the limiting lines of the little holes have their longitudinal axis. And then, because of some cuttings or interruption, Inventor couldn't create the axis of symmetry in the correct order. Use grip technique, hold this terminal point and then stretch the axis of symmetry. Okay, similarly hold this terminal point and stretch it. Hold this symmetry axis and make it in the correct order. Yes, third angle projection. Save the file, saying save as not first quadrant, but say that third quadrant. Object 1, third quadrant. April 28. Okay, dear students. I hope I achieved to demonstrate how the model created applying not cutting but material adding technique, partially cutting, partially adding, for such a geometry for which cutting method is not suitable. pure cutting method not suitable because there are some curved surfaces, and also the other reason, the volume of the part to trim is too much. Yes, then adding method is recommended. Okay, and also one more time demonstrated how the views are created in Inventor. Time to say bye bye. Okay, next video record may be just on the same example, but via using the tools of AutoCAD create the model. Okay. If you say that, hocam, I am quite good on model creation issue in Inventor and or in AutoCAD, then you can of course skip such video records. But in this video record, well, for the ones they are quite good on model creation thanks to the previously gained learning outcomes and your studying. But you see, I demonstrated one more thing at this stage: surface painting. It is a new thing. For the first time, talking about how the surfaces are painted in Inventor. So it became a complementary, valuable learning outcome, my dear students. Stay healthy. Bye bye.